Welcome back to another metrology and measurements session. Today we are going to discuss about the second unit, measurement of linear angular dimensions, assembly and transmission elements. My name is P.NAVIN JASS, Assistant Professor, Department of Mechanical Engineering, Rohini College of Engineering and Technology. So this is the syllabus for the second unit, measurement of linear angular dimensions, assembly and transmission elements. So this is the syllabus. In this unit, this is a very big vast unit, so many measurement instruments are available in this unit. So here in this unit we are going to study the various instruments. First one is linear measuring instruments and the angular measurement instruments. So there are 3 to 4 phases are in this unit. So in the first phase, linear measuring instrument, and in the second phase, angular measuring instruments. In the third phase and fourth phase, we are going to study about the assembly elements, and in the fourth phase we are going to study about the transmission elements. In the assembly elements, we are going to study about the measurement of screw threads and screw single element measurements, pitch diameter of the lead and pitch of the screw thread, and these are the things we are going to study. In the fourth phase we are going to study about the gears, measurement of gears and run out, pitch variation, tooth profile of the gear and tooth thickness of the gear, and these are things we are going to study. And also we are going to study about how we are going to check the gear in this process with the help of measuring instrument or measuring machine. So this is the course outcome of the second unit. So from this second unit we can able to deliver the impact of the measuring instruments to the students, and students can able to use of the principle and applications of the linear measuring instruments, assembly and transmission elements in the work purpose in the industries. So they can able to use the measuring instruments to check or inspect, or they can able to use the measuring instruments for the work purpose.
Okay, what is meant by measurement? Where we are using this measurement? Measurement is very important in various things. For example, to occupy the land and trade with his neighbors, they need some measurements. As the society has technically grown up more, much higher accuracy of measurement is needed in an increasingly diverse set of fields. Okay, length is the most necessary measurement in everyday life, and units of length in many countries still reflect on humanity's elementary methods. Now, these measurements are mostly used in various industries for quality control. There are two main different measurements of there. One is linear measurements and another one is angular measurements. What is linear measurement? It includes measurements of length, diameters, height and thickness. These are the measurements of linear measurements. Okay, now we are going to see about the 3 different classification of linear measuring instruments. First one is low resolution devices. Low resolution devices. In low resolution devices, first one is steel rule. Steel rule is nothing but is a steel scale with measurements, and steel rule with assistance of calipers, dividers, surface gauges, etc. So These calipers, dividers and surface gauges with an assistance of steel rule with dimensions. And the last one is thickness gauges. It is used to find out the thickness of the any element or material. Okay, next one is medium resolution devices. Second one is medium resolution devices. In this medium resolution devices, there are different devices out there. One is micrometer, micrometer with assistance of telescoping and extendable ball gauges. Then vernier calipers, dial indicators, and microscope. We are call it as measuring microscope. The third resolution is high resolution devices. In this high resolution devices, there are various devices on there. One is gauge blocks. Second one is gauge blocks with assistance of mechanical comparator, electronic comparator, pneumatic comparator, and optical flats. These are the three main classification of linear measuring instruments. Okay, different types of linear measuring instruments. What are the different types of linear measuring instruments? Vernier caliper, micrometer, slip gauge or gauge blocks, optical flats, interferometers and comparators. These are the different linear measuring instruments. Okay, today we are going to see about the topic vernier caliper. What is meant by vernier caliper? What is the use of this vernier caliper? What are the different types of vernier calipers? And what are the other instruments with a vernier scale? Okay. Okay, first one is vernier caliper. In this vernier caliper, there are main components are there. One is main scale, and this is the main scale, and vernier scale, fixed jaw, movable jaw, and clamping screw. Before we move on to this vernier caliper, we should know about what is vernier instruments. Vernier instruments have two scales of different sizes which are used to measure the dimensions in high accuracy. Dimensions in high accuracy. Various types of vernier instruments are we discussed about here. Vernier caliper, micrometer, slip gauge or gauge blocks, optical flats, and interferometers and comparators. Okay, now we are going to discuss about vernier caliper. We saw about components of vernier caliper. Now we should know about what is the vernier caliper. Vernier calipers are available in different sizes of 150 mm, 225 mm, 900 mm, and 1200 mm. The selection of the vernier caliper depends upon the measurement that we have to be taken. We should select the vernier caliper according to its need to measure the element. The vernier calipers are precision instruments, and we should take extreme care while handling the vernier calipers. Okay, this is the vernier caliper. There are different parts of vernier calipers on there. One is there's a fixed jaw and a movable jaw. There's a fixed jaw and movable jaw. And measuring tips are over the vernier scale for the measurement of internal dimensions. These measuring tips are used to measure the measurements of internal dimensions, and these measuring tips are fixed jaw and movable jaw have the measuring tips of to measure the external dimensions. And there's a clamping screw is there. And there's a vernier scale which is movable over the caliper. Okay, these are the different parts which are occurred on the vernier caliper. Okay, first we should know what is the working of a vernier caliper. First, we get a clear view of the vernier caliper parts. Now we are going to get the view of working of the vernier caliper. It has two steel rulers which slide one on each another. One of the longest scales is named as a main scale. So this is a main scale which is on the longer side of this vernier caliper and which is graduated on a L-shaped frame. So this main scale which is on a L-shaped frame. The vernier caliper consists of three elements such as beam, fixed jaw and a movable jaw. Fixed jaw and a movable jaw. So this movable jaw slides over the main scale according to the dimension of the specimen to be measured on the vernier caliper. So before starting the measurement, we should ensure that the scale is checked to 0. We should check the scale is to be 0 and two measuring jaws are in contact with each other. During the measurement, the fine adjustment screw of the movable jaw is done by adjusting an adjustment screw. At the same time, both the jaws should touch the part to be measured during the measurement. After doing the fine adjustment, the lock nut B is tightened. A final adjustment to be done depends upon the correct feel of the operator, which is based on the experience of an operator. After the final adjustment has been done, the lock nut A is also tightened to note down the readings. Verniers are used to measure both the internal dimensions and also the external dimensions. So this is the working of the vernier caliper, and we should know what are the different types of vernier calipers. There are three different types of vernier caliper. One is type A caliper, type B caliper and type C caliper. So this is the type A caliper. Here the internal measurements and external measurements are on the different sides. Here the internal measuring jaws are over the main scale, and external measuring jaws are below the main scale. Then here there's a type B vernier caliper. Here the internal dimensions and external dimensions are measuring jaws are on the same side. In type B vernier caliper, the internal measuring jaw and the external measuring jaw are on the same side of the vernier caliper. And as a type C vernier caliper, here also the internal measuring jaws and the external measuring jaws are on the same side, and there's an additional attachment which is attached above the main scale. We call it as a knife edge faces for the marking purpose. For the marking purpose, these knife edges are given over the main scale. So these are the three different types of vernier caliper. Now we should know about the vernier caliper least count. Here vernier caliper least count is nothing but it is the difference between the value of the main scale division and the value of one vernier scale division is known as the least count of the vernier caliper. So least count is equal to value of one main scale division divided by total number of divisions on the vernier scale. So let us assume the vernier scale has the total numbers of division as 10 and value of one main scale division as 1. We get the least count value as 0.1 mm. So here 1 by 10 is equal to 0.1 mm as least count. So least count of any caliper is the smallest value that we can measure from this device. To calculate the least count of the vernier caliper is the value of one main scale division divided by the total number of divisions on the vernier scale. So let us assume the value of one main scale division and the total number of divisions on a vernier scale 10 mm, the least count will be 0.1 mm. So the least count is defined as the smallest distance that can be measured from an instrument. So what is a vernier caliper? Zero error. We should know about what is vernier caliper. Zero error. There are three different types of zero errors on there. One is no zero error, positive zero error, and negative zero error. So we should know about what is no zero error. So no zero error, when we bring two jaws together, the zero of the main scale is coinciding with the zero. As it is shown in the figure, when we join the main two jaws, the vernier scale 0 and main scale 0 will coincide each other. That is called as no zero error. What is the positive zero error? If the positive zero error, when we bring the two jaws together, we can see the zero error of the vernier scale is head of a main scale 0. So when we see the 0, the main scale 0 is head of the vernier scale 0. So it is called as a positive zero error. So wherever it is ahead of the vernier scale, some point it will be coincide with each other. Here the 3 is coincide with each other. So we are calculating the positive error. So zero error is equal to coinciding vernier scale division into least count. The least count value is 0.01 centimeter. So the coinciding value is 3. So 3 into 0.01, we call it as we get the value of 0.03 centimeter as positive zero error. Then what is my negative zero error? When we bring the two jaws to each other, vernier scale 0 is ahead of main scale 0. That is called as negative zero error. Here, at some point, the number 8 is coincide with each other of the vernier scale and the main scale. So we get the calculation of the negative error. So coinciding division is 8. Difference between the total division and the coinciding division is 2. So zero error is equal to 2 into 0.01 centimeter. So we get the value of 0.02 centimeter as negative zero error. So we move it on the next topic, vernier height gauge. So here in vernier height gauge, there are different main parts are there. One is base, beam, measuring jar and scriber, slider, clamping screws, etc. These are the different parts of a vernier height gauge. So we should know about what is the use of the base and what is use of the beam, what is use of the measuring jar and scriber, and what is use of the slider. So first we are going to see about what is the use of the base and how it is made. The base is always it is rigid and stable. Rigid and stable. So it can withstand whatever the weight which is placed above the base, it can withstand the amount of weight. The base is ground and lapped well with an accuracy of 0.005 mm. 0.005 mm. It is ground and lapped well with an accuracy. And next one is beam. What is the use of the beam? It should be rigid in such a way it withstand 1 kg of weight. It can withstand 1 kg of weight. And it is applied upward at the tip of the scriber. The sliding edge of the beam should be perfectly flat within the various ranges corresponding to measuring ranges. The face of the beam should be exactly perpendicular to the base within 0.04 mm by 100 mm. And the next one is measuring jar and scriber. Measuring jar and scriber. This is the measuring jar and scriber. The projection of jars of the beam should be at least equal to the projection of the base. Both the upper and lower surfaces of measuring jar should be flat and parallel to the base. The actual depth of the scriber should be clearly marked on the surface of the element. So what is going to be slider? A provision is made, obtain a fine adjustment of the slider. To fit the slider perfectly, a clamp is attached with the slider. So we can adjust the slider wherever it can move upwards or downwards. We can able to find out. So this is the parts of the working of vernier height gauge. Next one is vernier depth gauge. Here the different parts of the vernier depth gauge is base, graduated beam, then clamping screw, fine adjustment mechanism, and vernier scale. This is the diagram of the vernier depth gauge. So this is the depth being measured. This is the vernier scale, and this is the main scale, and that's a fine adjustment screw, movable head, and a base. So here, a vernier depth gauge is one type of a vernier caliper. It's a type of vernier caliper. So graduated scale directly slides through the base, but the vernier scale remains stationary. When the main scale is slides through the base, but the vernier scale remains stationary at the depth gauge. So the instrument is mainly used for measuring the depth of holes, recesses, and distances from a plane. It is mainly used to measure the depth of holes and distance from a plane and recesses. So this is the main thing of the vernier depth gauge. So finally, today's session is over. Thank you